Hello and welcome. Today we are going to talk about how to run your Python code on GPUs. We are also going to talk about how to run multiple Python script at the same time. So for this demonstration, we are going to use Jupyter Hub, which is running on our remote GPU server. Jupyter Hub allows us to access Jupyter Notebook, which you are probably already familiar with, and also Jupyter Lab, which is the next generation notebook interface. It has support for integrated terminals, extension, and a lot of other good things. And all of this can be run remotely with Jupyter Hub. If you want to know more about it, you can go to jupyter.org and check it out. So let's get started with the demonstration. So before you run any code, you have to make sure that CUDA drivers are installed properly. We have already installed it, and we are not going to show how to install CUDA in this video. So to check the CUDA version and if it's installed properly, you can run NVCC version. Here we can see that we have the 10.1 installed, and we can check more details about this GPU by running NVIDIA SMI. It will show us the driver version, the CUDA version, and the power we are using, the GPU utilization, available memory, used memory, and what processes are using the GPU. So we have CUDA installed. Let's get started with the code. So by default, your Python code runs only on the CPU. To utilize the GPU, you need to use frameworks like Tensorflow or Pytorch because they are specifically written, or they have modules that allows them to use the GPU, utilize the GPU. So let's run this code. So by default, TensorFlow automatically detects and uses the GPU when possible. Here we are just importing the TensorFlow 2.0. Note that TensorFlow 1 works differently, where you have to separately install the GPU package, TensorFlow GPU. So and you don't have to do anything here. So you have your GPU. We have one GPU available, and it's showing that it's detecting that. Let's run this demo matrix multiplication code. We have the log place, so we can see that if our code is actually running on the GPU. So here you can see that it's running on GPU 0, and we have the result here. So it's working properly. You can see the GPU name and other things here. So this is pretty simple. And if you, for some reason, if you want to disable the GPU, you have to add this code here, and then let's restart the kernel. Okay, so we run the code again, and now if you see that the number of GPUs available is shown as 0, and now if we run the code, it will run on the CPU. So let's check the same thing for PyTorch. So for PyTorch, we have a simple PyTorch autoencoder. Let's run the code from the beginning. Here, to select the GPU, we have to check if CUDA is available, and then we have to select the device. Here you can see CUDA 0. So last time you saw that in TensorFlow we had GPU 0. Here we have CUDA 0. So this GPU, if CUDA is installed properly, all of your GPUs are assigned an ID, and normally it starts from 0. If you have multiple GPUs, then you will have numbers like 0, 1, 2, 3, and you can change this number to select the GPU you want to use. So let's run this, and our device is shown as CUDA 0. So this is good, but you have to note another thing. We have assigned device equal to CPU or device equal to CUDA 0 here. And to make sure you are using the GPU, you have to assign your model to the device using dot to device, and also you have to assign your data or load your data on the GPU by doing this to device. So let's run this. So it started running. Now we can run NVIDIA SMI, and we can see that the power usage is gone up. It's 40 watt. The GPU utilization is at 7%. The memory usage has gone up. So it's working as it's expected. To disable the GPU, if you don't want to use the GPU for some reason, you can write device equals CPU and then stop the kernel, restart it, and start from the beginning. So now we are running, setting the device equals CPU, and if we do that, it will run on the CPU, not on the GPU. Okay, so let's start the multiprocessing part. So here, if you want your code, if you want to run multiple scripts at the same time, uh, you can actually run it on multiple terminals. That's uh, easily doable. Or if you want to do it from the same notebook or same script, you can write a script like this. So what are we doing here? So we are listing all the scripts that we want. We are importing multiprocessing, importing OS, and we are listing all the scripts we want to run. Let's check script A, script B. Script A has a print, script B has another print. So if you have multiple scripts, you can list them here. Then we have a execute function, and this function just loads this script as a process on the OS, and we have a multiprocessing pool where we have two processes, and we are mapping the execution function with the all processes list. So if we run this, both our scripts run, and you can export this as a script like this, and you can run this. And uh, I forgot to show another thing, which is like this is the same matrix multiplication code from the TensorFlow example. So if you want to run it as a script and you want to disable the GPU on the go, so if you run the script as is, it will detect the GPU and run the code on the GPU. So PyTorch has CUDA 0, TensorFlow showing number of GPUs available is equal to 1. But if you want to disable the GPU on the go, you can add CUDA visible devices equals -1 and then Python script CUDA.py. Now if you run this, you will see that no CUDA capable device is detected. Number of available GPUs is 0, and PyTorch is saying that it's using the CPU instead of the GPU. So that's another way you can disable the GPU. There are some scenarios where you want to disable the GPU, like someone else is probably using it, or you are probably using it in another process, and you don't want to overload it. So there can be some scenarios where you may want to use it. So that's it for the demo. Hopefully you find it useful. Thank you.